So let's talk about graphing equations. We have this line here, and if you look at it, you'll notice that this line has a degree of 2, right, on the x value, and then the y has a degree of 1. So it's no longer a linear function. So it doesn't necessarily mean that it will give me a straight line. Why do I know this? Because we have a power of 2 here. The power of 2 tells me we're going to get some kind of parabola. In order to graph this without using a calculator, a graphing calculator to figure it out, what we would want to do is create an XY table. And all that you need is 2 order pairs to graph a line, but since it's not a linear equation, right? They're not both to the first degree. We're going to need more than 2 order pairs. So what I'm going to do is give myself enough room to come up with at least 4 or 5 order pairs. And I always like to start small, because if you go small, it's a little bit easier, and then you can X off the ones that are a little more complicated to graph and pick another point. So I like to start small. I like to plug in -1 for x, 0 for x, and 1, and then I can plug in 2. So now I'm going to take this equation over here, and I'm going to line it up, and everywhere as I see x, I'm plugging in my points. Now guys, if you want to plug in for y and find x, you could do that. A little helpful hint is if this was already set up for y, then I would plug in for x. So let me show you what I'm saying. If I was to go ahead and set this equal to y, that means I need to make 0 go away, or excuse me, make x go to 0 on this side. So I would subtract it, right, x squared, from both sides. And what happens now, I get this new function, which is the same equation, but and I called it function, but it's an equation. And I'll show you a function here in just a little bit. Like this. So you can use either one. Just be careful. Just make sure you do your math correctly. And then when you plug in the values for x, you automatically know what y is, and you wouldn't have to do that step over here where you subtract it. It is up to you. However, I do like this method here. If for some reason the y was squared and the x was to the degree of 1, then I would plug in for y, okay? So make it as easy as possible on yourself. So let's solve for y. And I'm going to give myself enough room. Alright. If I plug in -1 right here, -1 squared is just 1, right? And then bring down the 4 minus 1, which gives me what? 3. Alright, so now let's solve for the next one. So let's grab the 0. Well, if I plug 0 in for x, 0 squared is 0, 4 minus 0 is just 4. So I know that order pair. So now let's go back and plug in 1. 1 squared is just 1. That gives me 4 minus 1, which is 3 again. You see what happened? We got a point on both sides of this order pair here, so let's plot it. And we don't have to have the 2 now because we already know it. So let's plot this. Let's go to 0, 0, and the first order pair is -1 for x. So I'm going to go to the left one, and the y value is positive, so I'm going to go up, and it says 3, so we're going to go up 1, 2, 3, and let's put our dot right here. Go back to 0, 0, and let's do the next order pair. It said x is 0, but y is a positive 4, so I'm going to go up, right, because we're not going side to side since x is going to stay 0. And we're going to go 1, 2, 3, 4, and then go back to 0, 0 and plot the next order pair. It says y or x is positive 1, so we're going to go to the right one, and then it says y is positive 3, so we're going to go up 3. We're going to plot our point, and now we are going to do your best to curve it. There you go. We got our parabola. It opens downward. So yay. So that's graphing this particular equation. plugging in points. Let's go to the next one. So this one here says, let's graph this line. And we know it's a linear line because the degrees are to the power of 1. So we're going to get a straight line. And you're asked to use the slope-intercept form. So that means it needs to be written in this format in order to graph it. So I want you to take a little bit of notes here, guys, when I start talking about the slope. If you look, this is not written in this format. So what I need to do is get the x value on this other side. So it's 5 is a positive x, 5x. So I'm going to subtract it from both sides. And I'm just going to rewrite this all right here. So now I got negative 7y is equal to a negative 5x plus 14. And if you notice, we're still not written in the format we need. We need the coefficient on y to be a positive 1. So I want to divide by negative 7 because that's what undoes the multiplication between the negative 7 and y. And what I do to one side, I have to do to all parts. Alright, we are almost done here, so I'm going to clean this up. I know negative 7 goes into negative 7, positive 1. Positive 1 times y is y. So far, so good. Negative divided by negative is positive, and 5/7 does not reduce, and it is in my slope format, so let's leave it there. Alright, negative 7 goes into positive 14 and negative 2 times. So now I have everything I need to know. My slope is this 5/7, which is m. My y-intercept is the negative 2, which is b. And that's all I need. I can graph this line now. So I need to go to where, first things first, let me give you some notes right quick. First, when we graph this line, you want to plot the y-intercept. And in this case here, we know that the y-intercept is negative 2 because of that formula, but some people tend to forget what x is. X is always 0. So this order pair for my y-intercept is 0, negative 2. So that means I'm going to come over here at 0, 0, and I'm going to go down 2 because y is negative. And I'm going to go here. The next thing you want to do, you're going to plot the slope from the y-intercept. So wherever the y-intercept is where we're going to plot the slope from. So if you notice that my slope is positive, so we have a positive slope, that means that this line is going to go up, right? Well, another way to look at it is if the line, a slope is y over x. So if it's positive, we're going to go up number of y values. If this and to the right on number of x values. If the slope is negative, well, we're going to apply the negative sign to the y value. And that means we're going to go down the number of y values. And we're still going to go to the right the number of x values. There's another way to plot this, but sometimes it gets a little more complicated. And so I just always apply the negative or the positive to the y value and keep my right or my x always going to the right, and then there's less room for errors. So to plot the slope, we go right over here to the y-intercept, and I'm going to start there, and the slope is 5 for y, and it's positive, so I'm going to go up 1, 2, 3, 4, 5 places, and then once I'm there, I'm going to look at my x value, and I'm going to go to the right, and it's 7. So we're going to go 1, 2, 3, 4, 5, 6, 7, and plot it. Now, that's all I need to draw my line. So I can draw my line here, and I always like putting an arrow on it. But if you want to plot another point on this line, you can start where you plotted this blue dot, and you can go up 5 more, and then to the right 7, plot it, and you just keep going, and you can make your line longer. But all you need is these 2 order pairs. So that is plotting this line using the slope-intercept form. The next part is we have a function. It's a function because it's called f. In this case here, f of x. It could be g of x, h of x, k of x. What is it saying is we got a function of x that builds on x, and the end result gives me my y value. And then you're asked to graph this line, and if you notice that this line is written in our slope-intercept form. So just a little side note, guys, that this f of x is my y. It's just written in a function notation, and you read it f of x is equal to. So let's graph this line. It says that I have a slope-intercept of positive 4. So my y slope, oh excuse me, I said it's slope-intercept. I'm getting tongue-tied here. I might need to slow down. I apologize, guys. My y-intercept is this positive 4. So we're going to plot the y-intercept first. So I'm going to go to 0, 0. And since it's a positive, I'm going to go up. 1, 2, 3, 4. And I'm going to plot my y-intercept. This is where the line crosses the y-axis. X is 0. From here, I'm going to graph my slope. My slope is a negative value, so that means I'm going down the number of y's, and the y is 2, so we're going to go down 1, 2, and then I'm going to go to the right, whatever x is, and it's 3, 1, 2, 3, and now I can draw my line going through these 2 order points, and put arrows on the end saying that my line continuously goes. Okay? So I apologize for getting tongue-tied. So let's go to the next one. The next line here says that we have y is equal to negative 4, and that's all it gave you. Well, this here is telling me that my x is 0. It's also telling me that my slope is 0. How do I know this? That it's telling me that this is my y-intercept. I'm going to abbreviate. It's telling me it's my y-intercept. So let's plot it. Go to 0, 0 and go down 4 values for y. 1, 2, 3, 4. Plot it. Well, we need another dot another order pair in order to graph this line. So this tells me that if my slope is 0, my x is 0, then this tells me that my y value is constant here. Now, I said if x is 0, I just mean that gave me my order pair at negative 4. But my y value says it's not changing, because it says y equals negative 4 all the time. So then it doesn't matter what other points I pick as long as my y value stays that negative 4. And then I can draw my line. So my order pairs that I'm going to pick, my x is changing and my y is staying the same. So I get a horizontal line. So I could have said, negative 5 for x, comma, negative 4 for y. We got the 0, negative 4. Let's do the, on the positive side of x, and let's call it, let's say 7 for x, comma, negative 4 for y. It's just telling me that y is not changing, but x is. So I have a horizontal line, and I have a slope of 0. Okay? On this next one here, it says x is equal to 3. So that tells me that when it crosses the x-axis, y is 0. This also tells me that we have a vertical line, and that means that my slope is undefined. I'm going to abbreviate here. So this means x is never changing. X will always be positive 3. So I can come over at 0, 0 and go out 1, 2, 3 and plot that. That means I can go up and down this line here because x is never changing, but my y is. So I can say I have an order pair of 3, 4, right? My y is changing. I can say I have an order pair of 3, 0. And I can say I have an order pair of 3, -3. Because my y is changing and my x is not. It's staying the same. And I got this vertical line. I'm going to put arrow on it. It's an undefined slope. And this is graphing our equations and function notations. Thank you.